What is up, people? Welcome to lesson 10-3 for Algebra 1. Today we're going to talk about operations with radical expressions. Last time in class for 10-2, we talked about just simplifying radical expressions. But today we're going to talk about operations, how to add, subtract, multiply, divide them. I'm sure this is a long-awaited lesson, something you've been looking forward to. Well, guess what? It is here. Our objective for this lesson is to simplify sums and differences, adding and subtracting, and also to simplify products and quotients of radical expressions. Sound good? Sounds good to me. All right, let's go ahead and look at this lesson. So, you can use properties of real numbers, so things that you guys are kind of more familiar with, in order to perform operations with radical expressions. And in order to add or subtract them, we need to have what are called like radicals. Like radicals, very similar to like terms, where we have to have the same index and same radicand in order to add them. In this case right here, 3 square root 5 and 7 square root 5 are like radicals because they both have square root 5 in common. Whereas 4 square root 3 and negative 2 square root 2, they are unlike radicals because they do not have the same radicand. They have the same index, they're both square roots, but they're not the same radicand. So one thing that's always helped me, at least when I'm trying to combine like terms, combine like radicals, all right, I try to use this example as much as I possibly can. All right, if I had, let's say, $2 plus $3, what would you get? What's $2 plus $3? Well, you would get $5. Now, they're both in terms of dollars. They both are $2 or $3 respectively. So when you add like terms, when they're in the same term and they're both in dollars, we're going to keep our dollar sign amount. The same thing applied if I had what was 2x plus 3x. Well, you would get the same thing as 5x. They're both in terms of x. So when you add them or subtract, we're going to keep them in the same terms. Now, let's look at problem 1. What is the simplified form of each expression? What is 6 square root 11 plus 9 square root of 11? Well, I notice that they're both in terms of square root 11. So these guys are considered to be like, therefore we can add them. We would just add 6 plus 9 is 15, and we leave it as 15 square root of 11. There's nothing else I can do because square root of 11 can't break down any lower. I can't use a ticket method. This is a prime number. So our final answer would be 15 square root 11. Let's look at a subtraction problem. Here I have square root 3 minus 5 square root 3. Are they like? Yeah, they are, because they both have square root 3 square root 3. Now how would I subtract these? What is square root 3 minus 5 square root 3? Well, this is the same thing as 1 square root 3 minus 5 square root 3, which is the same thing as 1 minus 5 is negative 4 square root 3. And this would be our answer. So not too bad, not too bad. We have two different answers. All right, one was addition, one was subtraction, but they're both like terms. Let's go ahead and look at this example for Got It question number 1. What is the simplified form of each expression? So the first thing I'm checking to make sure is, are they like? And I have 7 square root 2 minus 8 square root 2. Are they like? Yeah, they are. So I have 7 minus 8 is negative 1, and they both, so I'm going to have negative 1 square root 2. And in this case, I can just simplify it and write this as negative square root 2. I don't need that negative 1 as a coefficient. It's kind of understood. If you wrote it like this, it would not be wrong. but this is a more traditional way to write our expression. Let's go ahead and try to add these two. Are these like? Say it with me. Ja, they are. So I can go ahead and add 5 plus 2 is 7. 7 square root 5. $5 plus $2 equals $7. So 5 square root 5 plus 2 square root 5 equals 7 square root 5. Not too bad. Now problem 2 asks a very similar, but I think I cut off some of it. It's like add circles. Sorry about that. All right, problem 2 asks a very similar but a very key difference in questions. What is the simplified form of 5 square root 3 minus square root 12? Can I in fact combine these? Can I subtract these? So the first question I would normally ask is, are they like? And you would say, no, no way. This is 5 square root 3 and this is square root 12. If they're not like, you can't add them the way that they are. But I also note that square root 12 is not simplified as low as it can go. In fact, what we learned last class, or last lesson, is that square root 12 is the same thing as 4 times 3, which is the same thing if the square root of 12 is the same thing as the square root of 4 times the square root of 3, which is the same thing as 2 square root 3. So really, this whole problem can be simplified and rewritten as 5 square root 3 minus 2 square root 3. And now, are they like? Ja. So let's go ahead and subtract. What is 5 minus 2? 3. Square root 3 would be our answer. So just because it might not look like it can be subtracted or added, doesn't mean it can't. It means we have to go a step further. We have to figure out, well, what is this in its lowest form? 3 is a prime number. It can't possibly go any lower. But 12 can go lower because it has a perfect square as a factor. Now remember, if you didn't like the perfect square factor method, you can use a ticket method. I can break this down to like 2 times 6, which is 2 times 3, which I bring this all the way down, and I figure out that this is the same thing as 2 squared 3. And the ticket method said that it takes 2 tickets to ride the ride, and 2 has 2 tickets, so he can ride the ride 1 time, and 3 stays home, and I end up having negative 2 square root 3 in any case. All right, so let's go ahead and look at the next one. Got it, question number 2. Let's just do example A. What is the simplified form of each expression? We look at our radicals, and we note that square root 7 and square root 28, they are not the same, so you can't add them the way that they are. 4 square root 7 can't go any lower because 7 is a prime number, but 28 can go lower. 28 is the same thing as, let's say, 7 times 4. So this is the same thing as 2 times the square root of 4 times the square root of 7. 4 times 7 is 28. Square root of 4 is 2. And square root of 7 stays the same. So this whole thing is 4 square root 7. So this is the same thing as 4 square root 7 plus 4 square root 7, which is going to give us 8 square root 7 is our final answer. Not too bad, not too bad. Just be careful when you're trying to simplify. Just make sure you're thinking about these things or using the method that works best for you. Can we talk about multiplication? Can we talk about multiplying radical expressions just for a second? Bear with me. All right. What if we wanted to multiply these radical expressions together? Problem 3 is asking, what is the simplified form of each expression? And for example A, we have square root of 10 times, and they give us a parentheses, square root 6 plus 3. Have we seen something like this before? To me, it kind of reminds me of distribution, right? Where if I had something like 2 times x plus 5, I would distribute. I would go ahead and multiply 2 times x and give us 2x, and I could also multiply 2 times 5 and give us 10. So this would be 2x plus 10. This looks very similar to what we are seeing right here. So square root 10 times square root 6. In fact, all we're going to do is just use our distributive property. Square root 10 times square root 6 is the same thing as the square root of 60. And then we can go ahead and distribute yet again. Square root 10 times 3 is positive 3 square root 10. Now, they're asking what is this simplified form? We would be done as long as nothing here can be simplified. But looking at this 60, I don't know. There might be something in there. So let's go ahead and try to break this up and see if this can go any lower, because we might be able to combine them. So let's go ahead and look at square root of 60. The square root of 60 is, let's use ticket method, as 6 times 10. We know that's true because we got the same thing up here. 6 is the same thing as 2 times 3. And 10 is the same thing as 2 times 5. That means the square root of 60 is the same thing as 2 squared times 3 times 5. Cool? Alright, ticket method, index of 2. 2 can ride the ride once, but 3 and 5 stay at home. So this is the same thing as 3 times 5 is 15. 2 square root 15 plus 3 square root 10. Can these be added together any more so? Nope. Alright, 10 only has factors of 2 and 5, can't go any lower. And 15 only has factors of 3 and 5, can't go any lower. Therefore, this would be our answer. What if we had to distribute using FOIL or box method? Either one would work. Let's go ahead and try that right now. FOIL. Alright, square root of 6 times the square root of 6 is the square root of 36. Square root of 6 times square root of 3 is the same thing as square root of 18. Then we can go ahead and do negative 2 square root 3 times negative 6 is negative 2 square root 18. And negative 2 square root 3 times square root 3 is negative 2 square root 9. There's a couple of things that we can simplify even further. The square root of 36 is just the same thing as 6. And the square root of 9 is just the same thing as 3. We still have a negative 2 right there. We have 1 square root 18 minus 2 square root 18 is negative 1 square root 18. The square root of 18 is the same thing as the square root of 9 times the square root of 2. So this is negative 1 times 3 square root 2. 6 and minus 2 times 3 on the outside. So if I simplify this further, I get 6 minus 3 square root 2 minus 6. Okay. Are there any like terms to combine? Well, the constants can be combined. 6 minus 6 is 0. So our final answer is negative 3 square root 2. So just be careful with it, be patient with it, and make sure that everything is lining up the way it's supposed to. Now, conjugates are quite interesting, at least to me. They're one of my favorite things in all of algebra. Whenever you guys have conjugate pairs, special things usually happen. And it's actually really important to understand how conjugate pairs and how distributive property, in this case, works, because this is going to save you a lot of trouble. Alright, so let's go ahead and look at this. Conjugates, if you guys don't remember, are the sum and difference of the same two terms. Another way to put this is the terms are the same, but the signs are different. square root of 7 plus square root of 3, square root of 7 minus square root of 3. The biggest difference is one is plus and one is minus. Now what happens if we distribute and we kind of do our FOIL first, outer, inner, last? Well, we would actually end up getting something quite unique. We would actually end up getting just one number by itself. Don't believe me? Shame on you. Let's go ahead and show a little work just to kind of prove this. Alright, if we went ahead and just did regular distribution, square root 7 times square root 7 is the square root of 49. Square root 7 times negative square root 3 is negative square root 21. Square root 3 times square root 7 is positive square root 21. And square root 3 times negative square root 3 is negative square root 9. I note that these two guys in the middle are like terms and they in fact cancel each other out. One's negative, one's positive, and left over I have the square root of 49, which is just going to be 7 minus square root of 9, which is 3. 7 minus 3 is 4, and this whole thing turns into a rational number, where we had square root 7 and square root 3, which were irrational, multiplied by its conjugate gives you a rational number. I wonder if that's going to be important. I wonder if we're going to be using that idea anytime soon. I don't know. I can hope, but I don't know. Let's look at the next example. Problem 4 says, rationalizing a denominator using conjugates. It looks like we are going to be using that concept we just talked about on the next example. What were the odds of that? Okay, what is the simplified form of 10 over square root 7 minus square root 2? Well, first off, is this simplified? We would say no, it is not simplified, because we're not allowed to have a square root in our denominator, let alone are we allowed to have just 2 just sitting there chilling. Now, what we want to do is we want to go ahead and rationalize the denominator. And in a previous lesson, we might have multiplied the denominator by itself, but multiplying this by itself is not going to get rid of my square roots. In fact, what we have to do is we have to multiply by the conjugates. So, first question, what is the conjugate of our denominator? Well, the conjugate of square root 7 minus square root 2 is square root 7 plus square root 2. So what I'm going to do is I'm going to multiply this by square root 7 plus square root 2. Because this is math and math is fair, I have to multiply the top by the same thing, because this is the same thing as 1. This divided by itself is going to give us 1. Multiplying by 1 does not change the value, it changes the way it looks. Mathematical wizardry. Alright, now that I did all of this, let's see what we get. Okay, multiplying the bottom. If we went ahead and did the long way around this, multiplying conjugates, you can do all of the distribution, sure, but remember, conjugate pairs form difference of squares when you multiply. So, the difference of squares form would be square root 7 squared minus square root 2 squared. So this is the same thing. Square root 7 times square root 7 is just going to be 7 minus 2, which will give us 5 as our denominator. Now that's amazing, because already I can tell that this is a much better answer than just leaving it like this. We are allowed to have 5 in our denominator. We are not allowed to keep this as our denominator. So we're going to go ahead and just multiply across the top. I'm going to kind of run out of space. 10 times square root 7 is 10 square root 7. And we'll just, you know what, for now, what we can do is we can leave it like this. Alright, I just multiplied across there. Now, 10 square root 7 is 10 square root 7 plus 10 square root 2. 10 square root 7 plus 10 square root 2. Cool. Now this is a good answer. Now remember, they're sharing a denominator, so if I wanted to, I could split this up to 10 square root 7 over 5 plus 10 square root 2 over 5, right? And notice that this guy and this guy reduced to change the color, a 1 and a 2, and a 1 and a 2. So it looks like my answer is going to be 2 square root 7 plus 2 square root 2. That's kind of weird. Oh, I boxed through that. There you go. Alright, so a few different steps. Number one, this is actually a lot easier than it looks. Whenever you multiply by the conjugate, it's always just going to be the radicand minus the radicand. 7 minus 2. 7 minus 2 is 5. That was nice and easy. Then on this case right here, we just have to be careful when you're trying to reduce. Crossing this 5 and the 10 does work, but technically you're dividing them both by 5. There's two different terms on top, so there's two different division problems that we'd have to go through. Cool, cool. Alright, the very last thing we're going to go over today, this last got it question, just to give you a little bit more practice. What is the simplified form of negative 3 over square root 10 plus square root 5? The first thing I want to do is I want to identify that I have to multiply this by its conjugate. Multiply by the conjugate. The conjugate of square root 10 plus square root 5 is square root 10 minus square root 5. Because this is math and math is fair, multiply them both by the same thing. Cool. Now, we notice that these two guys are conjugate pairs. Conjugate pairs make difference of squares. So this is going to be the same thing as 10 minus 5. Square root of 10 squared is 10. And square root of 5 squared is 5. Now, on the top, we're going to have negative 3 times square root 10 minus square root 5. We're going to end up getting negative 3 square root 10 minus or plus 3 square root 5. Why is it plus? Well, we do notice that we have a negative sign and a negative sign multiplied together would give us a positive sign. Over 10 minus 5 is 5. There's nothing else that we can do. This might be an appropriate answer where we can leave this like this. Again, that kind of looks like a weird 3, so that's a 3. Oh, that was a mistake. I should have just erased it all. It's a weird 3. Erase. And then rewrite. 3. Right? Another possible form you could have wrote this as is negative 3 square root 10 over 5 plus 3 square root 5 over 5. Notice the 5 and the 10 and the 5 and the 5 cannot cross cancel because this is in a radical sign and this is not. Either of these answers would be appropriate. I believe the homework gives answers like this one. Alright. But this is also a good answer. Alright, that concludes this lesson. Hope you enjoyed it. Use all of this stuff for the rest of your life starting now.